May 2015, C2. We're just going to scroll through to question 1. Here we go. It's binomial. There is a formula for binomial which is given in the formula book. It will look something like this. A plus b to the n is equal to a to the n plus n1 or nc1, a to the n minus 1, b to the 1, plus nc2, a to the n minus 2, b to the 2, all the way to b to the n. This is if n is a positive integer. This is a special case of the binomial, really, where it ends up with a finite number of terms as per NC2. So that's the formula as it's given. One of the few things that we need to know need to look at is the structure of this, is that these powers should always add up to whatever the value of n is. You'll notice that. So they always add up to, in this case, always going to add up to 10. And also that the powers of n, the powers of the a bit go downwards. So we've got n, n minus 1, n minus 2, and so on, down to n, basically naught, to the power being naught. And the ones that b go up to, b to the naught, b to the 1, b to the 2, and finally finishing off with b to the n. So we should always look at that structure when we're looking at the binomial. Right, so let's just work this out. It does ask for the first 3 terms, so let's not waste our time and give any more than the first 3 terms. So 2 minus x to the 4 to the power 10 equals 2 to the power 10, that's our a to the n, plus 10c1 2 to the 9 minus x over 4 to the 1 plus 10c2 2 to the 8 minus x to the 4 to the power 2, and we don't need any more terms. And so let's work out each of these bit by bit. 2 to the power of 10 equals to 1024, and then it's minus 10, that's 2 to the power of 9, which is equal to 512 x over 4. Notice the minus the minus that was here, I have now put here. I could have put it, sometimes it's worth knowing that we're going to always have alternating signs when we have a negative here. So the next one will be positive. So that's plus 45, 2 to the power of 8, that's 256, x squared over 16. Do be careful there, because a lot of people would forget to square the 4. And so early on the paper, we really want to get all the marks. So now it's equal to, if we work that out, this is 1024. This, it's not on a calculator, you are allowed to calculate here, so you're just going to work out for this one, because it's on the bottom, 10 times 512 divided by 4, basically. And for this one, you're going to do 45 times 256 divided by 16, because the 16 is on the bottom. Okay, so that basically will break down to minus 1, 2, let's get that colour correct, minus 1280 x plus 720 x squared. And that's it. First 3 times, first question done. Okay, let's go on to the second question. They've left a space there for plenty of space for us to get question 1 done, so we didn't really need all that. So now we're on to question 2. It's a pretty straightforward circles question, as we'd expect it to be at this stage. The equation of a circle, which you need to know, is x minus a squared plus y minus b squared equals r squared. Now, where a and b is the centre and radius r. So we could work out r. We know the centre of the circle. This is the centre. We can easily work out r. We can either put it in the equation and work it, or we can just work it out straight away. R is equal to the square root of the difference in the y coordinates. So that's minus 5 minus 1 squared, plus the difference in the x coordinates, 4 minus 2 squared. And if we work that out, that gives us r equals to the square root of 20. I suppose we could have equally got rid of the square root sign, in fact, because it's not r itself. We can just say r squared equals 20. It looks a bit neater that way. R squared equals 20, because we want r squared in our formula. So that's it. X minus a, which is 2 squared, plus y plus 1, because minus 1 squared, equals 20. And that's it. Remember, the radius here is the square root of 20. It's not equal to 20. So that's the first part done. Okay, now the second part, B, find the equation of the tangent to the circle at A, given that given it in this form. Okay, right, now what we need, if I draw a quick diagram here, it may help. There we go. You probably don't need a diagram to answer this type of question, because you can probably picture in your head, but just for the sake of explanation here, I need a gradient of the radius I've just drawn in blue there, and then I'm going to use the fact that it's perpendicular to work out the gradient of the tangent here. And then I'm just going to use the fact that I know a coordinate on the point, and I know the gradient to work out the equation. So the gradient of the radius change in y over change in x, or whichever way you want to write it, y2 minus y1 over x2 minus x1. That's the change in y. The change in y is equal to minus 5 take away minus 1, so it's minus 4. The change in x is equal to 4 take away 2, so that's 2. So that's equal to minus 2. But we want perpendicular to that, the tangent, so that's equal to a half. Okay, so now there are a couple of approaches to working out the equation when we know a gradient and a point. I tend to use the standard formula, the quotable formula, but some students don't like to remember that, and it is perfectly okay to just put into y equals mx plus c and then work out c. So we've got y plus 5, because it's y minus y1, is equal to a half x minus 4. Okay, so that's the equation. We want it in, it does, the question does say ax plus by plus c equals to 0 form, so we better do that. Double in both sides, we get 2y plus 10 is equal to x minus 4. Taking those two over, you get 2y minus x plus 14 equals to 0. Okay, which is the answer. So that's fine. Let's just move on to question 3. Probably have to scroll through a few blanks pages. There's one blank page. Okay, right. So, right, it's still in relatively comfortable territory here. This is standard factor theorem. And the factor theorem says if x minus alpha is a factor of a polynomial being any, well, example is quadratic, cubic, and so on, then f alpha equals 0. Or it's reversible, this one is if and only if. So x minus alpha is a factor if polynomial f alpha equals 0, or if alpha equals 0, x minus alpha is a polynomial. So we can use it in either direction. Now, we're told that x plus 1 is a factor. Oh, this is not actually factor theorem, it's remainder theorem, which is related. Let's write that down as well. Remainder theorem. If ax plus b is a factor, let's write this out again. The remainder when dividing a polynomial fx by ax plus b is given by f of minus b over a. It might be written the other way around, so some people write it, it doesn't really matter. Sometimes we have a different sign, minus there and plus there, whichever way. Doesn't matter, I'm going to go back to where I started, but it doesn't matter which way. The point is you must recognise the change of sign. So here, a is 1 and b is 1, so we basically then therefore know, using the remainder theorem, that f minus 1 is equal to 45. So we're just putting minus 1 in there in the polynomial we're given at the top there. So that's 6 times minus 1 cubed plus 3 times minus 1 squared plus a times minus 1 plus b equals 45. So that makes minus 6 plus 3 minus a plus b equals 45. So that that gives us minus 3, which when we take it over gives us b minus a equals to 48 as required. Okay, so that's the first part A. Only 2 marks, obviously, for that, because really it's just a matter of putting it in there and then breaking it down. Factor theorem. So the factor theorem is this bit of information here. Remember the change of sign is basically telling us that f minus a half equals to 0. So we're going to put that into our polynomial. So that's 6 times minus a half cubed plus 3 times minus a half squared plus a times minus a half plus b equals 45. So that tells us, change the size a bit. Okay, so that tells us that 6 times minus 1 over 8 plus 3 times 1 over 4, remember double negatives, minus a over 2 plus b equals 45. Okay, so looking at these first two terms here, I think they're going to cancel. Minus 6 over 8 plus 3 over 4, they're the same thing. So that's minus a over 2 plus b equals 45. So this bit here is minus 3 over 4, and this is plus 3 over 4. So they're going to disappear. So if we write that out and double it, we get 2b minus a equals to 90. Oh, whoops, I've just seen the mistake. Of course it's not. It was a fact, it's not a remainder of 45 anymore. It's not. So that was silly. So we've got a is equal to 2b, in fact. So we're going to solve this by substitution, because we can just put a is equal to 2b back into the formula. So sub for a. So we can sub the a that we have from there back into there. That gives us b minus 2b equals 48. So that gives us minus 2b, minus b equals 48, or b equals to minus 48. But if b is minus 48, because a is 2b, that must mean that a is equal to minus 96. Okay, so that's that part of the question done. Okay, now on to the next part, because if we go back to the question, it now says factorize fx completely. Okay, so we're going to the next part of the page. We knowing a is minus 48, so b is minus 48 and a is minus 96. Okay. So we just started gone on to the second page here. So we're now factorising that, but we were told earlier on that there was a factor. If we scroll back to it, we were told that 2x plus 1 is a factor. Okay, so we know that. Now it's tempting at this stage to just put 2x plus 1 and then do long division with it and all the rest of it, but there were a few things that were missed when I marked some of this. One was there's a common factor already of 3. 2x squared plus x cubed, 2x cubed plus 3x squared plus x squared minus 32x minus 16. Okay, well, you can't just get rid of it as some people did, so just decided they were going to cancel the 3, because so often in questions we have it equal to 0, and then you're used to kind of things cancelling down. It's not, this is the function here, so we can't just suddenly decide that a function is 3 times smaller than it was from what it was from before. So the 3 has to stay there. We're not solving an equation, basically. We're writing a function. So we can now do long division on the rest of this if we want to. I'm not going to do that, but we could do. We could do 2x plus 1 into the rest of this expression. And then work out all that stuff, all that down there. Or the grid thing, I know the grid is quite popular as well, 2x plus 1, or horizontally and vertically, and work out the quadratic bit. See my other video, you'll see that I often just kind of hardwire this and just write it out. Don't have to, just quicker if you can. So I would encourage those who want to do it, because it's certainly not you're not losing any method marks for just writing out the function. We know that this has got to be x squared here because we need a term in x cubed. Okay, so that works that term out. We know also that the final term must be minus 16 because we need to get to minus 16 here from these two. Okay, so it's a case of making sure that we get the middle term right. So the first two terms, the beginning and end, are easy, and a little bit more thought for the middle one. So what I'm going to do is look at how I'm going to look at my term in x squared here. So, and then try and see see that I've got a term in x squared from these two. Okay, a term in x squared there. And what I see actually is it must be naught x squared here, because I've already got x squared. So there must be no there must be no term in x squared here, because I've already got exactly x squared from the 1 times the x squared. And I want to get x squared. I would then also, because obviously it's slightly unusual, I'd then be inclined to check that the term in minus 32x also works out. Well, when I times those two out, I also get minus 32x. So that's it, folks. I left myself a load of space for a middle term that actually is not there. Okay, in long division it would have come, or whatever, you would have come up with a 0x term. Okay, so x squared minus 16. Not done yet though. Examiners have really made sure that, I'm going to put us through our paces, make sure that we don't just carelessly move on. That's a difference of 2 squares. And that's the final answer. Okay, quite a few number of you, we know pretty good math students have missed out on a mark there for classic one is to miss the 3 out at the top front, or to just write this and not fully factorise at the end. So we're seeing all kinds of variations of this which will lose in a mark. For example, this loses a mark because 3 is not out as a factor, and so on. Okay, so that's that. Okay, so we've got a Radians question for question 4. Right, okay, so the first question show that COD, that's this angle here, is equal to 0.906 radians. Well, we are told the radius of the circle effectively here, because, oh well, we're told it explicitly, 8. Okay, so we can work that out from, we can work this angle out from the fact that we know that this length is 8 and the side opposite is 7. Okay, we can use the rule, which basically says that it's basically the cosine rule rewritten. As it's written in the formula book, it goes like this: a squared equals to b squared plus c squared minus 2bc cos a. But if we want to rearrange that to get the angle, that's b squared plus c squared minus a squared over 2bc. A is the one that's opposite the angle. So in this case, A is going to be 7 and our B and C are going to be 8. Okay, so it should work out quite nicely. So that's cos A is equal to 8 squared plus 8 squared minus 7 squared over 2 times 8 times 8. And that equals to 79 over 128. Not forgetting, obviously, A is the inverse cos of that. So that gives us, or the arc cos, That gives us A is equal to 0.906 to 3 significant figures as required. Okay, so that's the first part. The second part, give the perimeter of OBCDA given your answers to 3 significant figures. So that's the perimeter of this whole shape here. Well, what do we know? We know quite a lot actually. We know the 7, we know the length all the way from here. We just need to work out the length of these two arcs and they will be the same. Okay, because it's telling us that these two angles are the same. So how are we going to work out that angle? Well, we'll use the fact that the whole of this is pi, and we now know that this is 0.906, this angle here. So the angle AOD, say, that's the left-hand one, the other one, well, I'll write them both out, AOD, and the angle BOC, is equal to pi, which is the whole 180, because they must add up to 180, minus this angle here, minus this 0.906. I will put the exact answer in now, which is actually start on 0.9056 and some other stuff, all divided by 2, because there's 2 of them, so that they all add up to pi. So that gives us that angle equals to 1.12 to 3 significant figures. Okay, so that's all we really need to know for the perimeter, because that so that means the perimeter is equal to the 16 at the bottom, the 7 at the top. Let's put this other stuff out. So 7 at the top, plus 2 times, and the formula is r theta for the length of our arc, is r theta. So, but we've got 2 of these, so that's 2 times by r, which is equal to 8, times by 1.12. Okay, and that actually comes to 20. No, it doesn't. It comes to 40.9 if you work all that out. Okay, so that's that part done. Now going on to the final part, the area of this whole shape. Well, we know everything we need to know now to work out the area. Let's put it here just to make room for it. The area is going to be the area of this triangle. So let's call it the triangle ODC. There's a useful formula for that, which is equal to the area of a triangle is equal to half AB sine C. So that basically means that the area is equal to half times the 2 sides on the 2 sides adjacent to the angle, times by the sine of the angle, which we've already worked out to 0.906. But I've got the actual number again memorized in the calculator, but actually that comes to 25.178. and a whole lot of other stuff, because I'm using it, not the exact answers, but I'm using the memory on the calculator to give an accurate answer to avoid rounding errors, because I do need it to 3 significant figures at the end. Okay, so that's the triangle. The sector area, of course, we've got 2 of these, but the formula there is equal to half r squared theta. So that equals to half times 8 squared times by theta, which we worked out a little while ago, 1.12. Again, I'm writing 1.12, but I'm using a more accurate answer stored on the calculator. And that number comes to 35.77, a whole lot of other stuff. Okay. Now, so I need the required area, which is going to be equal to 25.17 blah blah blah, plus 2 times, because there's 2 of them, the sector area, 35.77. Okay, and that, when we actually work it out all together, that comes to 96.7. To 3 significant figures if we work it out. Okay, let's move on to the next question. Question 5. Scroll through the blanks first. Blank again. Quite a few blank questions. Okay, well, it looks quite a nice series question here. Let's see. May not be quite as nice as it seems. We've got all the terms positive, and the first 2 terms is 34, and sum to infinity is 162. Rather than, if we're using the formula for the first 2 terms, which would seem unnecessarily complicated, I'm going to use A, which is the first term, plus AR is equal to 34. Quite a number of students I saw use the formula, which is okay. If you do that, you end up with r squared over 1 plus r. But then you need to make sure that the top bit factorizes. It's a bit unnecessary, but it's okay. But it's not okay if you don't factorize it. So you'd have to do 1 minus r, 1 plus r over 1 plus r equals 34. And we've got to cancel the wrong thing, because it was 1 minus r on the bottom. Just rushing this too much because I want to get on with the paper. But 1 minus r. Rub this off again. Wishing I hadn't started this now, but I know some students did do this, so I just want to make the point it would have got you there, but what a number of you did was not cancel, and you ended up with horrific cubics in the next part. Wasn't necessary to do any of that if we recognise that the first 2 terms were A and AR. And then it says the sum of the first 2 and the sum to infinity. Now there is a formula in the formula book for the sum to infinity. It goes like this. Okay, that's actually given in the formula book. So that's telling us that 162 is equal to A over 1 minus R. Okay, so we've got to basically eliminate A and R from this equation. Right, well, how are we going to do this? Various things we could do. I'm inclined to do this. A times 1 plus R equals 34. I can then, if I use this expression here, say A is equal to 162 times 162 times 1 minus R. So I can now substitute for A into here. Okay, but there's various ways about going about it. The main thing is that we're not dealing with cubics, because that's not good. So we've got 162, 1 minus R, 1 plus R equals 34. Okay, so there's a little bit of cancelling down that can be done here with the 34 and the 1462 before we go any further. Not a lot. It's 81, 1 minus R. But I can also multiply that out. 1 minus R squared is equal to 17. So we get 81 minus 81 R squared equals 17. So we get 81 R squared if we jiggle this about a bit, is equal to 81 minus 17, which is 64. That's good. We've got some square numbers here. R squared is equal to 64 over 81. Some of you, we're so used to drumming in the fact that this is going to be plus or minus 8 over 9, but the question does say they're all positive. Okay, so we must really get rid of that negative in the plus or minus, which isn't applicable here because it says so in the question. It's not applicable, that all the terms are positive. In fact, looking at the scheme, plus or minus did forfeit a mark because you've not used the fact that it says that they are positive here. Okay. So you do have to read the question, in another circumstance, if the question hadn't said that and you'd only written 8 over 9, you'd lose the mark for not writing plus or minus. You've got to answer the questions as they're written. Okay, let's go to the second bit. A different geometric series as first term 42 and common ratio 6 over 7. Find the smallest value of n for which the sum of the n terms exceeds 290. Okay. So let's put that in the geometric series formula. It needs to exceed 290. So there is a formula given in the formula book, which is Sn is equal to A, 1 minus r to the n over 1 minus r. Okay, so we have 42, 1 minus 6 over 7 to the n over 1 minus 6 over 7 must exceed 290. Right, okay, now if I look on the bottom of this, that I get a 7. 1 minus 6 over 7 is 1 over 7. So I'm effectively timesing the top, the 42 by 7 when I flip that over. So I'm going to do that now. So 42 times 7. $294. 1 minus 6 over 7 to the n must be greater than 290. Let's multiply that out. 294 minus 294, 6 over 7 to the n is greater than 290. So then let's isolate this term here. It needs the inequality is going to change direction here. Notice 294, 6 over 7 to the n has got to be less than or equal to 4. Because I've juggled it that way. Hopefully you can see the inequality is in the right direction there. By variety I means it must reverse. Okay. Dividing that by 4, I get 6 over 7 to the power of n is less than 4 over 294. Okay. I'm going to take logs both sides, logs base 10. I prefer to do that really rather than deal with logs base 6 over 7 or whatever, but it is possible to do that way. So taking logs both sides, we end up with this. Okay. Now, when using the rule of logs, that means that n log 6 over 7. Remember, log, if I don't write 10, base 10 means base 10. So the base is base 10 here. And now I'm going to divide through, but remember, once I divide through, my inequality has to change direction because I'm dividing by a negative. log of 6/7 is negative. And check it out. It's because basically the log is less than 1, so it's the only way that we're finding a log of something less than 1, so that's the only way it can be. So it's negative, so which is why both numbers are negative, so they cancel. But the inequality reverses, so that gives us n is greater than 27.9, so n equals to 28. We must finish with the 28. Now, a couple of points here. That's enough to get the question done. A couple of points before I move on. One, of course, the answer would have been 28 even if I'd had 27.2, because it needs to exceed the value 290. Okay, and it's got, n goes up in integers, so it needs to exceed it. So 27 would be below, and 28 would be above. So we would have to we would go above even if the number was below 0.5. The other thing is, can you use trial and improvement? Well, it's not really good maths, but on this mark scheme, I can't guarantee that it would be on any mark scheme, but trial improvement would be accepted. But if you did, you would have to show that the answer for n is equal to 27 and the answer for n equals 28, and show that one is below and one is above. Otherwise, you will not get full credit. I'm not encouraging it because you never know. I don't know. I'm not on the C2 marking team, so I wouldn't know, but it is accepted. But you would have to go either side and check the value 27 and 28 and show that one's below 290 and the other one's above 290. Okay, let's move on to the next question. Blank page, blank page, blank page. Okay, so we've got first bit is just an integration bit, as you might have been stated in basically C1. It could have been. Okay, let's change colour. We've got integral of 10x x to the half minus 2 dx. So that's equal to the integral, let's multiply that out, 10x to the 3/2 minus 20x dx. So we're going to add 1 to the power and divide by that number. So that's 5/2 x to the 5/2 minus 20/2 x squared plus c. Don't forget the plus c, even though it's on C2. You never know, they might be penalise you for it. They definitely would on C1. I don't think it did on this scheme, but we should have the c there really, because whenever we're doing integration without limits, indefinite integration, we should see a c. Anyway, that's not, it does say, I think, simplifying the terms, so that's not good enough. So if we simplify those terms, it's 10 over 5/2 is 10 divided by 2.5, which is 4x to the 5/2 minus 10x squared plus c. And that's the answer. Okay, the next part is to find this shaded area here. So it's a definite integration. Now, when we integrate, we have to split it into two bits because part of it's below the line and part of it's above the line. So if we work out 4 naught and 10x to the 3/2 minus 20x dx, it's going to be a negative answer because it's below. It will come negative. So we work that out and it's going to come negative. We'd be worried if it didn't. And then we integrate between 4/9, between 9 and 4. That should be positive. And then we add the two areas together, remembering that a negative area, a negative integral, obviously we ignore it, we modulate it basically to get the actual area. So we've already integrated this. And now we don't really want to see the constant now. It's not wrong, but it's unnecessary. So that's 4 to naught. So that gives, when we put 4 to 0 in there, that gives equal to 4 times 4 to the 5 over 2 minus 10 times 4 squared. Take away 0, all the other bits are going to be 0 in this case. So that equals minus 32. But that just means the area is 32. Okay. Now, the integral from 9 to 4, remember we would expect a positive thing here because it's above the axis, is equal to this bit here. Let's put the limits in. That's equal to 4 to the 9 times 5 over 2 minus 10 to the 9 squared. Take away the value 4 put in, that's 10 to the 4 to the 5 over 2 minus 20 times 4. Work all that out properly and carefully, and that equals 194. So the required area is these two added together. So we modulated the negative 32, so it's 32 plus 194, so that equals 226. Okay, I've used a bit of space there. Remember, this is I'm using this on my tablet here, but obviously you can't go over the lines in the mark scheme. Okay, so we would have gone on to the second page, which is there, plenty of room for it there, and another page, and another page, and here we are on to question 7. Okay, so question 7 is a logs question. 8 to the 2x plus 1 equals 24. I might be inclined to use the log base 8 button here rather than take logs to the 8, logs to base 10 on both sides. So if we take logs to the base 8, we can say that 2x plus 1 is equal to log to the base 8 of 24. Undoing the logs there. So that's makes it quite nice and straightforward, I think, hopefully. So we've the main thing is getting these things in the right place and not getting confused with the log, with what the log does. So then that makes that basically, if I rearrange that, 2x is equal to log 824 minus 1. So x is equal to log 8 of 24 minus 1, all divided by 2. That's the exact answer. Obviously, they want the answer to 3 decimal places. So if we actually work that out to 3 decimal places, that comes to 0.264. Okay. Okay, so we've got a rule of logs kind of equation thing going on here. There's a little bit of a thing about it that some people are not dealing with this, the two bits together here. And I'm seeing lots of stacked fractions in work. So what I've seen is, it's not wrong, but you know, students do it one by one or doing one thing over the other. So what the typical kind of thing I've seen is log 2 11y minus 3, that divided by 3, which is the first bit, bringing those two together. This bit then divided by y squared, and then having to deal with that, and some people dealing with it correctly and some not. I'm going to bring these two bits together really first. I suppose I'm going to write it like this. It's not absolutely necessary, but it just seems to me, if I bring these two bits together, first. So I do say, as long as you can deal with stat fractions, all the rest of it, as long as you don't have to. But I think this is quite a nice way of doing it. Using the rule of logs, first of all, we get log 2 11y minus 3 minus log 2 3 plus log 2y squared equals 1. That's basically using the power rule that n log x is equal to log x to the n. Important rule of logs. And then I can do log 2 11y minus 3 minus log 3y squared equals 1. That's using log x plus log y is equal to log xy. Okay, I'm getting a little bit careless with the bases. They're all base 2s here. Now I can bring the thing together. Because that's why I did this. It avoided stack fractions or thinking about what I'm going to do with a stack fraction, which is why I did these two first. I suppose you'd have to. The important thing is to remember the plus. So that's basically using this rule of logs here. Log x minus log y equals log x over y. Okay, so now we can undo this because we've got 11y minus 3 y squared must be equal to 2 to the power of 1, which is of course equal to 2. So now I can multiply this all out. I get 11y minus 3 is equal to 2y squared. Okay, bringing it all over now, I get, oh, sorry, there's obviously a 3 there and a 3 there. Forgot about it in there. Right, yes, that's a 3 there, so that makes that 6y squared here. So that makes it 6y squared minus 11y plus 3 equals to 0. So factorising that gives me 3y minus 1 and 2y minus 3 equals 0. So we've got y equals to a third and y equals 3 over 2. And that's that question done. Okay, let's go on to the next question. Go scroll through the blank pages first. Okay, so we've got a trig question here. Okay, so it's radians first of all, so a little bit of need to take care that we're working in radians. So let's just do a bit of reorganizing here. I can see that because of the 0 here, and we're going to be using sine theta over cos theta equals 0. So we might be bothered by the 3 theta, but that's so long as these are the same, that's generally true. So we've got cos 2 theta over sine 2 theta equals 0. What I'm talking about equals tan theta. Sine 2 theta over sine 2 theta over cos 2 theta equals tan 2 theta, and so on. So the 3 theta isn't going to bother us, as long as the angle's the same. So part A, or part 1. So we have sine 3 theta is equal to square root of 3 cos 3 theta. So we have tan 3 theta. Oh, let's write it out, let's not rush it. Sine 3 theta over cos 3 theta equals square root of 3. So tan 3 theta equals to the square root of 3. So now we're working in radians, and it's questionable whether I would change the mode of the calculator to radians here. You can always work in degrees and then convert to radians. So to convert from degrees to radians, times by pi over 180. Okay, so you can always think in degrees or work in degrees, even write it down in degrees, so long as we convert. Right, so first of all, if we work out the principal value on our calculator, that's going to come to, well, let's just imagine we're using degrees. When we inverse line out, we get 60 degrees. If you use the radian, if you're in radians mode, because you've decided that's how you're going to work it, then you're going to get pi by 3. Okay, now with tan, to get all the other solutions, it's quite straightforward, isn't it? We can just times by just add 180 to it, and looking at it, we need to go between 0 and pi, or 0 and 180. So we need to go between 0 and 180, but because we're timesing by 3, we really need to, for 3 theta, we need to go between 0 and 540. So we need to stop at 540. So we have 60 and add 180 to that and we get 240. Add 180 to that and we're going to get 420. Add 180 to that and say we're beyond the 540, so we've gone beyond. Okay, so that's all our solutions in degrees. Theta is therefore equal to 20 divided by 3, 80 divided by 3, and that equals to 140. Okay, you would lose a mark here if we're in radians. I think at least 1 mark, but we can easily convert, so we can times by pi divided by 180 here. So we get theta is equal to pi by 9 and 4 pi by 9 and 7 pi by 9. Okay, if you don't mind working in radians, it'd probably save a little bit of time, but I know some students don't, so it's just as well to work like that. You know, it doesn't really cause too many, for some students it causes less difficulty. Okay, so question 2. Bit weird, really. A bit. It says find cos x in terms of k. So they're trying to change it, kind of trying to mix it up a bit here. But it is, I think it caused a few problems because it was a bit unusual. We are going to use an important identity, which is sine squared x plus cos squared x equals 1. So that gives us we can replace the sine squared in the formula there with 1 minus cos squared. Okay, so let's just do that then. So we've got 4 times 1 minus cos squared x plus cos x equals 4 minus k. Right, now what happened to most here is a lot didn't know how to proceed here. It is a quadratic though. 4 minus k, and that means that we get, if we rearrange that, we get 4 cos squared x minus cos x minus k equals 0. If I put that into the quadratic formula, which is, if you've forgotten it, well, you shouldn't have done, hopefully. That gives us cos x is equal to minus b, which is 1, plus or minus the square root of b squared, so that's minus 1 squared, so that's 1. Take away 4 times a times minus k all over 2a, which is 8. Simplifying, that's 1 plus or minus the square root of 1 plus 4k over 8. Okay, not many people actually managed to answer that because I think it was felt a bit unusual to some of you. Okay, now going back to the next part of the question, which is when k equals to 3, find the values. Now what quite a few people, and it was retrievable, if you had no clue what was happening here, it was retrievable to put the k equals to 3 here and then work with what is then perhaps a little bit more standard question, plus cos x equals to 4 minus 3, which is 1. And then to do all this stuff that with the cos squared at that point, which of course if you haven't managed to do part A is perfectly okay. However, if you have, then it's not obviously a good idea because we've already got cos x in terms of k. So we can sub in k equals to 3 into the equation. So we've got k equals to 3, which is cos x equals to 1 plus or minus the square root of 1 plus 4 times 3 all over 8. So that gives us cos x, if we work all that out, is equal to 1 times by, well, just a sec, yeah. Oh, of course, I made a mistake here. It should have been 16 because 4 times 4 is 16, which makes that 16 times 3 here. So that equals to 1 plus or minus the square root of 49 over 8. And that gives us cos x is equal to 1 plus 7 over 8, which is 1, or 1 minus 7 over 8, which gives us minus 3 over 4. So we're solving two equations. We're working in degrees now. So we've got cos x equals to 1. That will give us the solutions 0, if you work out that. And we have to add or subtract lots of 360, which basically takes that out. It'll only give us x equals 0. Can try and look for other solutions, but there won't be, because one of the solutions is 0, and the add 360 to that, we're already outside our range because it's not allowed to be equal to 360, and of course taking 360 will be outside our range because it can't be negative. So that's that one done. So let's solve the cos x equals minus 3 over 4. So in this one we can work out the principal value of minus 3 over 4, and that gives us 139. So we have x is equal to 139. But remember, with the cos function, it's an odd function, so there's another solution which is the negative of that, minus 139. Okay, so this is for cos only. One solution, principal value. The other solution is minus the principal value. Principal value is the one the calculator gives you. And any other solutions from that, we're going to have to add 360. We'll add in 360 to this one, obviously jumps over where we want, but not adding 360 to this one. So that gives us the other solution, which is equal to 221. When we add 360 to that, I'm just going to list all of them. So you've got x is equal to 0, 139 and 221, because we don't need to write that one because it's outside our range. So that's our solution to that. Okay, so that's the trig question done. Okay, I would have gone to a second page just here. So let's look how many pages we would go through. So I would have used that page, another page, another page. So it's a couple of pages not used. So, okay, so question 9. Right, it's a differentiation question. Okay, it's one of these practical differentiation questions which seem to be quite popular with examiners and somewhat less popular with students. You've got a cylinder, so I'm going to draw my cylinder. Not a very good drawing of a cylinder, but there we go. Now we're told that the cost of polishing is £2 for the curved surface of it, and for the tops and bottom. So really this is split into a top and bottom, and this curved bit here, some of you might remember this kind of thing from GCSE. The height of this thing is h and the radius is r. So if you imagine the curved bit here, this curved bit around here, all the bit there, that if you were to kind of roll that out, the length of that would be equal to the circumference of the circle. Yeah, circumference of that. And so the curved surface bit is 2 pi RH. So the area of the curved surface is equal to 2 pi RH. Okay, the area of top and bottom, well, that's just the two circles, which are both pi r squared. Is equal to 2 pi r squared. Okay, so we've got costs here, and it's told us the volume. Now remember, the volume is the cross-sectional area there times by length. So the volume is equal to pi r squared h. Okay, now we're told the volume is equal to 75 pi. Now, a lot of people don't like, a lot of students, as I say, don't like these types of questions, but they will always involve some form of substitution. So we've got 75 pi is equal to pi r squared h, and because the thing that we've been asked to show does not have a h in it, we're going to substitute for h. So let's get an expression for that. Well, let's notice also the h cancels. So we have h equals 75 over r squared. So that's the thing we're going to use to substitute in there. Okay, let's just minimize that a little bit. So back to the cost aspect of it. Now the cost, we are told, is £2 per centimetre squared for the curved surface area. So that's 2 times by 2 pi RH. That's the £2 aspect of it. And £3 for the top and bottom. So that's 3 times 2 pi r squared. So that is the curved surface there, and that 2 pi r from the curved surface. This one's a curved surface here, and the other one's the top and bottom. Okay, so simplifying that, we get C is equal to 4 pi RH plus 6 pi r squared. Okay, so now we can substitute for H. So we have C is equal to 4 pi r times by 75 over r squared plus 6 pi r squared. Now we've actually done it. Now because we've been asked to show this, we can write that as 300 pi over r plus 6 pi r squared. And the clue is in the answer. We've been asked to show this, but we can see that it is 300 because of the 4 times the 75. So don't worry that I've written them the other way around, but if we want to be OCD about it, we can reverse it, but it's not necessary. We can both see it. We can see that they're the same thing. Okay, so that's the first part. Now, if you're not able to do the first part, do make sure you can go through to the second part. If that's not possible, if something's gone wrong, it doesn't quite come out for you, hopefully you might have picked up a few marks. Remember, it's all about substituting, using what you've been given. Here, in this case, it was the volume to get an expression for a variable which isn't in the final formula, which you substitute for. In this case, it was h. Now, if you can't, if it doesn't work out for you, then hopefully you can still go on for the part B. So we need to work out, it says use calculus to find the minimum cost. Calculus, by the way, is differentiation and integration. In this case, differentiation. So to find the minimum cost of polishing, given your answer to the nearest pound. So we've got dc by dh is equal to. Now, don't worry about the pi bit being, it's just a number. You know, it doesn't look like a particularly friendly number, but 6 pi is going to be about 19 or something like that. So it's just a number. So if we differentiate that, that's 12 pi r. Differentiate this bit, I suppose it might have been more helpful to write it as this. Again, 300 pi is just a number. So that's, we're going to times by that minus 1. So it's minus 300 pi r to the minus 2. Okay, so we are now solving the equation that equals to 0. Because if it's a minimum, dc by drh, dc by dr, not dz by dh, dc by dr is equal to 0. So that's 12 pi r minus 300 pi, let's write it this way, r squared is equal to 0. Okay, so that I can just cancel the pi first of all, so, and divide by 12. So divide by 12 pi basically, I'm going to get r minus 12 divided by 300 divided by 12, which is 25, over r squared equals to 0. So that, if I multiply that out, that gives me r cubed minus 25 equals to 0. So r cubed equals to 25. So r equals to the cubed root of 25. Okay, so, and that equals to, approximately equals to 2.92. Approximately. But I'm going to put the exact answer into our thing. It does say find the minimum cost. So we found the value of r for which it's a minimum cost. So then we put c equals to, and let's put that back in, 6 pi r squared, which is, so we can just put the cubed root of 25 squared, plus 300 pi over the cubed root of 25. And if we work that out carefully with our calculator, we should get the answer. 483. The reason why I've hesitated is I've used the memory on my calculator, and it is 483 rounded downwards. My truncated decimal is 483.4843085, but they want the nearest pound. The mark scheme was generous. It gave the correct answer if they wrote 484 as well. Did want it to the nearest pound, so the best answer is 483 because that is to the nearest pound. It's the correct answer. The mark scheme did accept 484, much to my displeasure. It's not really right. Anyway, justify the answer that you have obtained to part B is a minimum. Now, in this case, we can differentiate again. So we've got dc by dr. Let's work out the same thing again. That equals to 12 pi plus 600 pi r to the minus 3. Okay, now there is only one mark here. They only want us to say that it's positive, so this is always positive. So greater than 0, always positive. You don't need to put the number in to see that, or shouldn't need to put the number r is equal to cubed root of 25 in there, because we can see that 12 pi is positive, and r to the minus 3, the cubed root of the 1 over 2.92 cubed, it's going to be positive. There's no negatives involved in any of our calculations, so it's always positive. So therefore, do finish off, it's a minimum. Okay, so this video has taken an hour and 16 minutes. We've had, you've got 90 minutes for the paper, but of course I've been chatting on about certain things, so hopefully you can realise that you've got plenty of time if you know what you're doing to answer the questions. And also, again, let's scroll through the number of pages. An extra page, of course, I have used an extra page effectively because I didn't want to. I've got that extra page here, but I've got another page, so that I've used that page, one more page, so it's actually used one more page, and I need one fewer page than I actually needed to. Okay, so that's it. That's June 2015 done and dusted. Hope you enjoyed it.